Have you ever stood outside at night alone and felt it? Not the cold, though maybe the cold was there too, biting at the back of your neck, making the skin on your arms pull tight. Not just the quiet, though the quiet was enormous, there was something else. Something that crept in through the eyes the moment you looked up and truly saw the sky. Not glanced at it, not noticed it the way you notice a ceiling, but really looked and let it look back at you. That feeling, the one that starts somewhere behind the sternum and spreads outward like ice water finding every crack, that is not imagination. That is not poetry. That is your nervous system doing something that took 4 billion years of evolution to become capable of recognizing, in the span of one long exhale, that it is impossibly, almost grotesquely small. Mira. Most people spend their entire lives carefully avoiding that feeling. They glance up, they say something like pretty, and they go back inside to make tea. But every once in a while, someone stands there longer than is comfortable. Every once in a while, someone lets the size of it land. And what happens next is one of the most important things a human being can experience, because in that moment, two doors open. One leads to terror. One leads to wonder. And the extraordinary, almost criminal truth is that both doors open onto the same room. What room is that? We will get there. But first, stay outside for just a moment longer. Look at what you're actually seeing when you stare at the night sky. The light entering your eyes right now left its source years ago. Some of it left decades ago. Some of it left before your grandparents were born. You're not looking at space, you're looking at time. Every single point of light is a message from the past, arriving at exactly this moment, landing on exactly the retinas of a creature that evolved on a thin, wet rock, orbiting a perfectly ordinary star in the suburbs of a galaxy that is one of somewhere between 100 billion and 2 trillion galaxies in the observable universe alone. And somewhere out there in that almost unimaginably vast darkness, there is silence. Total, complete, absolutely deafening silence. No radio signals, no laser pulses, no structured transmissions of any kind that we have detected in over 6 decades of listening. We have been cupping our hands around our ears and pointing them at the cosmos since 1960. And not once has anything answered back. Not once. And here is the question that should be keeping you awake at night. The question that kept some of the most brilliant minds of the 20th century genuinely unsettled. Why? Why is the universe so impossibly large, so incomprehensibly old, teeming with billions of worlds that could in principle host chemistry similar to ours, and yet so absolutely, thoroughly, terrifyingly quiet? There is a word for this, a word for the shape of that silence, a word that names the thing that has no clean answer. I will get to it. But first, you need to feel the weight of the question, because if you skip past the weight, the word means nothing. Imagine you're a child and you walk into a party, a big party, hundreds of people laughing, eating, talking, and you walk through every single room and not one person looks up. Not one person waves, not one person says your name. The room is full of life, and yet for you, it is as if you do not exist. Now scale that up. Scale it up past your neighborhood, past your city, past your continent, and your planet and your solar system. Scale it up past the 400 billion stars in the Milky Way, past the nearest large galaxy 2.5 million light years away, past the walls of superclusters and the filaments of dark matter threading the cosmic web together. Scale it up to a universe that is 93 billion light years across in all directions just in the part we can see. And ask yourself again, why the silence? Why is there no one at the party? That question has a name. I will say it when the time is right. What matters now is that you understand this is not a whimsical philosophical puzzle for bored academics to bat around after dinner. This is the central survival question of the human species, full stop. Veras, there is a version of this story that is comfortable, and it goes like this. Space is very big, life is very rare, we are probably alone, and that is a little sad but ultimately fine. Put on your coat, go back inside, make that tea, but that version, while emotionally convenient, is scientifically irresponsible because the numbers do not support it. The numbers, when you sit with them honestly, the way a scientist has to sit with numbers they would sometimes prefer not to look at, the numbers suggest something far more disturbing. And if you're still here, if you have not looked away yet, then you're exactly the kind of person this conversation is for. The universe is approximately 13.8 billion years old. Earth is 4.5 billion years old. Life appeared on Earth almost as soon as the planet cooled enough to allow liquid water, roughly 3.8 billion years ago. Intelligence, something like what we have, appeared in the last blink of cosmic time. If the entire history of the universe were compressed into one calendar year, modern humans would appear in the last 14 seconds of December 31st. But the universe had billions of years before us. Billions of years during which stars formed, burned, exploded, seeded space with carbon and oxygen and iron, died, and gave birth to new stars with planets. Billions of years of chemistry, billions of years of possibility. And given how quickly life appeared here once conditions were right, you would expect, statistically, that life should have had plenty of time to emerge elsewhere. Not just microbes, but complex life, technological civilizations. Species that looked up at their own night sky, felt that same icy feeling behind the sternum, and decided to do something about it? Species that built radio telescopes or lasers, or something we have not even thought of yet. Species that in billions of years of head start should have colonized significant portions of the galaxy, or at minimum, left some detectable trace of their existence. And yet nothing we have found. Nothing we have heard. A cosmos so large it strains mathematics to describe it, and apparently completely, stubbornly, silently empty of anyone else. Think it, if this does not make your throat tighten even a little, check your pulse, because either life is so rare that we are functionally alone in a universe of 2 trillion galaxies, which is its own brand of existential horror, and this is the option that should make you set down your cup. And lean forward, there is a reason why civilizations do not persist. There is something, some threshold, some transition, some trap that civilizations reach and from which they do not return. And we have no idea whether we have already passed it or whether it is still ahead of us. This channel exists because these questions are too important to leave only to specialists. If any of this is landing somewhere real inside you right now, if your mind is starting to stretch in that uncomfortable but exhilarating way, subscribe, not because of an algorithm, but because the people who keep asking these questions out loud are perhaps literally the ones who give our species the best chance. And leave a comment below. What do you think the silence means? Your answer matters, because the conversation about where humanity goes from here needs more voices, not fewer. Now, let us talk about Mars. Everyone wants to go to Mars, and that sentence by itself tells you something fascinating about human beings. Face it with evidence that our planet is the only confirmed home of life in the universe, faced with a pale blue dot suspended in a shaft of sunlight in the black of space. The very first instinct of a certain kind of human mind is, let us leave. Let us go somewhere else. As if the answer to our cosmic loneliness is to spread that loneliness thinner across more planets. And there is something genuinely moving about that impulse. And something that also requires honest examination, because here is what Mars actually is. Mars is a dead world, not quiet, not sleeping, not waiting for us. Dead, its core cooled billions of years ago. When the core cooled, the magnetic field died. When the magnetic field died, the solar wind stripped the atmosphere away over millions of years. The average temperature on Mars is negative 63 degrees Celsius. The thin remaining atmosphere is 95% carbon dioxide. The surface is bathed in ultraviolet radiation at levels lethal to unprotected biology. There is no liquid water on the surface. The dust contains perchlorates, chemical compounds toxic to human biochemistry. A dust storm can cover the entire planet and last for months. And we want to go there, and genuinely, the wanting is not crazy. The wanting makes sense. The question is whether we are clear-eyed about why, and whether we are honest about what it would cost. Getting to Mars takes between 6 and 9 months, depending on the orbital alignment. During those months, the crew is exposed to cosmic radiation at levels that significantly increase cancer risk and may cause measurable neurological damage, including degraded cognitive function, memory problems, and changes in emotional regulation. We know this because we have studied astronauts on long missions, and we have studied the biological effects of radiation in detail. The radiation problem is not small, and it is not solved. Once on the surface, every single thing the crew needs to survive must either come from Earth or be produced locally from materials that are not cooperating. Oxygen, water, food, heat, protection from radiation, medical care. Every margin for error is razor thin. A single seal failure, a single system malfunction at the wrong moment, and human beings are breathing Martian atmosphere, which will kill them in roughly 2 minutes. Mira, none of this means we should not go. But it means that anyone who frames going to Mars as a straightforward solution to humanity's long-term survival is, at minimum, oversimplifying in a way that matters. Because the mental model of Mars as a backup Earth, as a second chance if we wreck this one, is not supported by the reality of what Mars is. If we render Earth uninhabitable while we are still in the early stages of Martian colonization, the people on Mars are not survivors of humanity. They are a small, isolated, incredibly vulnerable group of humans trying to stay alive on one of the most hostile surfaces in the solar system, dependent on a supply chain from a dying home planet. That is not a backup. That is a very sad epilogue. The honest version of why we should go to Mars is not that it saves us. The honest version is that it teaches us. Going to Mars forces us to solve problems we have not solved yet. It forces us to develop closed-loop life support systems that might eventually have applications here. It forces engineering breakthroughs in energy, materials science, medicine, and communication. It forces us to confront our biological limits and design around them. And it forces us to ask the question quietly in the backs of our minds. The question that every Mars mission carries as invisible cargo. If we do not find life there, does that tell us something about how rare a life is? And if we do find even the chemical traces of ancient life, does that change the probability calculus for life everywhere in the universe, and therefore for why we might be hearing nothing? Going to Mars, in other words, is one of the finest things humans could do, but not because it rescues us, because it educates us, because it keeps alive the one thing that might actually determine whether we survive as a species, the ferocious, undiminished will to understand. But we need to stay honest about the cost. And the cost brings us back to the trap. There is something that civilization after civilization, if there were others, may have encountered. A bottleneck. A point at which the technologies capable of expanding a civilization's reach are the same technologies capable of destroying it. Nuclear weapons are the obvious example on our own timeline. We developed the ability to split the atom and release energies that power stars, and within a decade we had pointed that ability at each other. We came by multiple documented accounts of people who were in the room when the decisions were made, very close to using them. Not once, multiple times. The Cuban Missile Crisis is the one everyone knows, but there were others. There were system malfunctions that triggered false alarms. There were individual human beings standing at consoles at 3 in the morning who had to decide alone and whether the thing they were seeing on a screen was real. Now, artificial intelligence, biotechnology, synthetic biology, climate systems destabilized faster than our political institutions can respond to. Any one of these in the hands of actors who are either malicious or simply not thinking carefully enough about second and third order consequences has the potential to do things that are difficult to walk back. The technologies of flourishing and the technologies of annihilation are not separate toolboxes. They are the same tools. The question is always who is holding them and what questions they are asking. And here is where the silence in the sky starts to feel less like a gentle mystery and more like a cold hand on the shoulder. Escucha, what if civilizations routinely make it to roughly our level of development and then, not through malice necessarily, but through a combination of hubris, short-sightedness, and the perfectly natural tendency to prioritize immediate comfort over long-term survival, they stop asking the important questions? What if the transition from a civilization that is curious to a civilization that is merely comfortable is the threshold? What if the most dangerous thing is not the bomb or the algorithm or the engineered pathogen, but the gradual, quiet, socially acceptable extinguishing of the need to know? That is a different kind of fear than the obvious ones. It is the fear of the slow room, the fear of a civilization that does not go out with a bang but with a shrug. That decides that the questions are too hard, or too uncomfortable, or not sufficiently profitable in the next quarter, and puts them down and picks up something easier. Something that feels good. Something that does not require looking up. If you feel a cold current moving through this right now, like a window left open in a room you thought was sealed, good. Stay with it, because we are just getting to the part where the fear has a shape. The shape is this. We may be living in the most consequential window of time in the history of our species, possibly in the history of life itself on this planet, and a significant portion of our collective attention is elsewhere. Not because people are stupid. People are not stupid. but because the systems we have built, the economic systems, the information systems, the political systems, reward short-term thinking. They reward confidence over uncertainty, simplicity over complexity, and comfort over the kind of productive discomfort that drives real understanding. And the universe does not care about our systems. The universe operates on its own schedule, according to its own rules, and it will not slow down while we sort ourselves out. The grand filter, there it is. That is the concept I have been circling. The shape that the silence takes when you give it a name. Not a single filter, necessarily, a single choke point that kills everything. But the idea, proposed by economist Robin Hanson and developed by many minds since, that somewhere in the path from simple chemistry to spacefaring civilization, there is something that almost nothing survives, a filter. And the question is whether it is behind us or ahead of us. If it is behind us, then the emergence of eukaryotic cells or sexual reproduction, or the specific neurological architecture that supports recursive language and abstract thought, one of those transitions was so improbable that it has only happened once, or almost only once in the observable universe. That would explain the silence. It would make us extraordinarily, almost cosmically rara, and while that is lonely, it is also in a strange way hopeful. It would mean we got through the hard part. It would mean the path ahead, while difficult, is ours to walk. But if the filter is ahead of us, if every civilization that has reached our technological level has, without exception, hit a wall from which it has not emerged, then the silence is not evidence of our rarity. It is evidence of our fate. And the way you tell the difference, the way you figure out which scenario you are in, is not comforting. Because if we look up and we start finding life, primitive life, microbial life, chemical signatures of biology on Mars or on the moons of Jupiter or Saturn, if the universe turns out to be full of life that simply never made it past a certain stage, then the filter is probably still ahead of us. The more life we find, the worse the news. Verás, that is the structure of the argument, and it is genuinely terrifying in a way that does not resolve neatly. Most terrifying ideas resolve. You figure out the solution. The fear dissipates. You move on. The great filter does not resolve. It sits there. It asks questions back. But here is where we turn. Here is where, as someone once did most brilliantly with every intimidating idea in science, we look the thing in the face and ask, okay, but what do we actually do with this? Because that is always the real question, is it not? Not just what is true, but what do you do with what is true? The universe is big. It is old. It is mostly empty of everything except hydrogen and time, and the occasional clump of matter arranged into something that briefly thinks about itself. What do you do with that? The first tool, the most important tool, is this: make the distinction between not knowing and not caring. They are completely different psychological states, and the difference between them is everything. There is a famous story about a young student asking about the nature of empty space, asking whether the vacuum between galaxies is truly nothing or whether something is there. And the answer, the real answer, is that the question has not been fully resolved. The vacuum has energy, measurable energy, what physicists call vacuum energy or zero-point energy. It fluctuates. Particles pop in and out of existence in timescales so short they are almost philosophical. Empty space is not empty. It is seething with potential, with borrowed energy, with the quantum foam of reality at its smallest scales. And the honest answer to whether we fully understand this is no, we do not. Our best theory of the very small and our best theory of the very large are incompatible with each other in ways that have not been resolved despite decades of effort by some of the most brilliant minds humans have ever produced. Said, that is not a failure. That is an invitation. The places where theories break down are not embarrassments. They are the most interesting places in all of science. They are the doors that have not been opened yet. Not knowing, held correctly, is not paralysis. It is orientation. It tells you where to look. Caring about the unknown, feeling the pull of the question, is the engine. And the absence of that pull, the decision that the questions are someone else's problem, or too complicated, or already settled, that is the slow filter. That is what the silence might be made of. The second tool is what we might call comfort with scale. And this one requires practice because the human brain was not built for cosmic scale. Your brain was built to track prey across a savanna, to remember the faces of about 150 people, to plan roughly as far ahead as the next season. It was built for a world of tens of kilometers, not tens of billions of light years. When you encounter numbers like 93 billion light years, or 14 billion years, or 2 trillion galaxies, the brain does something reasonable and slightly unfortunate. It turns the numbers into sound. It processes them as language rather than as magnitude. 93 billion and 93,000 produce roughly the same internal response, which is big, and that flattening is a problem. The way to counteract it is to build analogies that bring the scale back to something you can feel. If the Milky Way galaxy were shrunk to the size of the continental United States, the solar system would be roughly the size of a quarter. A single quarter somewhere in the vast interior of a continent, in a galaxy that is one of at least 100 billion. The nearest star to our sun in this analogy would be about another quarter sitting roughly 40 meters away from yours. The universe is not just big in the way a continent is big. It is big in a way that genuinely overwhelms the analogy. And yet all of it is made of the same stuff. Every atom in your body was forged in the nuclear furnace of a star that died before the Earth existed. The iron in your blood was made in the core of a collapsing star. The oxygen you are breathing was synthesized in fusion reactions that happened billions of years ago. You're not looking at the universe from the outside. You are the universe looking at itself. And that sentence is not poetry. It is chemistry, it is nuclear physics, it is thermodynamics. It is the most accurate description of what a human being is that science has so far produced. Comfort with scale does not mean pretending the scale is not terrifying. It means letting the terror and the wonder occupy the same space, which, as it happens, is exactly what they do in the observable universe. The third tool is what we might call productive uncertainty. The ability to act, to make decisions, to live a life, while holding open questions rather than forcing premature closure. This is harder than it sounds. The psychological pressure to resolve uncertainty is intense and nearly universal. We are storytelling animals, and stories have endings. Ambiguity is uncomfortable. But the universe is almost entirely made of things we do not understand yet. Dark matter makes up roughly 27% of the mass energy content of the universe. We know it is there because of its gravitational effects. We have no idea what it is. Dark energy, the thing that is causing the expansion of the universe to accelerate, makes up roughly 68% of the mass energy content. We have even less idea what it is. The stuff we understand, ordinary matter, atoms, the things we can see and touch and smell, the stuff with weight and texture, and the faint metallic smell of old coins in your hands. That accounts for roughly 5% of what exists. 5%. Scientists are not embarrassed by this. Or rather, the good ones are not. The good ones find it thrilling, in the way that finding an entirely unexplored continent would be thrilling. There is so much more to know. The map is mostly blank, and blank maps are not evidence of failure. They are evidence of how much adventure remains. The fourth tool is perhaps the most personal, and it has to do with black holes. We promised you black holes, and here is where the terror and the wonder converge most completely. A black hole is what happens when enough matter is compressed into a small enough volume that the escape velocity, the speed you would need to travel to break free of its gravity, exceeds the speed of light. Nothing travels faster than light. Therefore, once you cross the boundary called the event horizon, nothing gets out. Not matter, not information, not, as far as we currently understand, anything. But here is what is genuinely astonishing, and what your brain will try to flatten back into comfortable abstraction if you let it. At the center of a black hole, according to our best theory of gravity, general relativity, there is a singularity, a point of infinite density, and a point of infinite density is not a physical object. It is a place where the equations stop working. It is where our description of reality breaks down entirely, where space and time as concepts cease to function in the ways we rely on them to function. A singularity is not a thing we do not understand. It is a marker at the edge of understanding itself. And every large galaxy, including ours, has one of these at its center. At the center of the Milky Way, roughly 26,000 light years from where you're sitting, there is a supermassive black hole called Sagittarius A star. Its mass is approximately 4 million times the mass of our sun, And we know it is there not because we have seen it directly, not at first, but because we watch stars near the center of the galaxy moving. We track their orbits over decades with incredibly precise instruments, and the orbits made sense only if something of that mass was sitting at the focal point. Invisible and dense beyond imagination, bending space itself into a cup from which nothing escapes. In 2019, the Event Horizon Telescope, which is not a single telescope but a network of radio telescopes spread across the Earth, coordinated to function together as an instrument the size of a planet, produced the first direct image of a black hole's shadow, not the black hole itself, which by definition cannot be seen. The shadow, the silhouette of the event horizon against the glowing material falling into it, it looked like a dark circle surrounded by a ring of fire. It was the most technically demanding photograph in human history, and it matched exactly what Einstein's equations, written more than a century earlier by a man sitting at a desk with a pencil, predicted it would look like. That matching is the thing. That is the thing to hold on to when the scale gets too large. A human being sitting at a desk with no computer, with no telescope, working purely from first principles, from the logic of how space and time relate to matter and energy, wrote equations that correctly described the behavior of an object 4 million times the mass of the sun and 26,000 light years away, decades before we could check. The universe is not random noise. It has structure, it has logic, and human minds are capable of finding that logic. That is not a small thing. That is in some ways the most remarkable thing. Fíjate, black holes do something else that matters enormously for the question of life in the universe. They produce jets. When matter falls into a supermassive black hole, it does not fall in smoothly. It forms an accretion disk, a spinning disk of superhot material spiraling inward, and the magnetic fields and the angular momentum of the system can launch jets of particles out from the poles of the black hole at nearly the speed of light. These jets extend for millions of light years. They carry enormous energy. They can sterilize entire regions of galaxies. They can, and in some cases demonstrably, have heated the gas in galaxy clusters so thoroughly that star formation stops. The black hole at the center of a galaxy is not passive. It regulates the galaxy. It influences over millions and billions of years which regions get to form stars and which do not, which regions might be conducive to life, and which are bathed in lethal radiation. The universe is not a neutral stage on which life either appears or does not. The universe is an active system, with processes operating on scales of millions of light years, that shapes and constrains the conditions for life. Life does not just happen against a backdrop of empty space. Life happens, if it happens at all, within a complex, evolving, occasionally violent cosmic ecosystem, and we are still learning the rules of that ecosystem. We have been studying the sky seriously, with instruments for a few hundred years. The universe has been running for 13.8 billion years. Our data set is almost comically small. Our conclusions should be held accordingly, firmly enough to act on, loosely enough to revise. Now the word for the silence, the concept I have been building toward from the first paragraph. The Fermi paradox, named for Enrico Fermi, physicist, one of the architects of the atomic age. A man who could estimate the number of piano tuners in Chicago from first principles, who once, over lunch in 1950, looked up from his food and asked his colleagues, "But where is everybody? Where is everybody?" 3 words. The most compact statement of the central mystery of intelligent life in a universe of this size and age. Not a solved problem. Not a question with a comfortable answer on either side. A question that sits at the intersection of astrophysics, evolutionary biology, probability theory, geopolitics, and the philosophy of mind, and refuses to resolve cleanly. The Fermi paradox is the silence given a name. And what do you do with it? You do what Fermi did. You sit with it. You run the numbers out loud. You resist the temptation to resolve it prematurely in whichever direction feels most comfortable, either reassuring yourself that we are fine and unique and special, or catastrophizing yourself into paralysis. You hold it open and you let it do what the best unanswered questions always do, pull you forward. Here are the practical instructions. Here is the Feynman toolkit for living in a universe this size without losing your mind. First, love the question more than the answer. The answer, if it exists, will come from people who fell in love with the question. It will not come from people who found the question annoying and wanted to be done with it. The history of science is littered with discoveries made by people who would not stop asking a question that their colleagues considered settled. The history of human extinction scenarios is populated by civilizations that decided they already knew enough. Fall in love with the question? Second, notice the difference between certainty and confidence. Certainty is the belief that you cannot be wrong. Confidence is the ability to act on your best current understanding while remaining genuinely open to being updated by new evidence. Scientists are supposed to be confident, not certain. The moment you become certain, you stop being a scientist and start being something else. In a universe where 5% of the mass energy content is the stuff we understand, certainty is not a scientific virtue. It is a cognitive liability. Third, make the abstract physical. Every time a number or a concept floats out of reach into pure abstraction, bring it back. 4 million solar masses. What does that mean? The sun is a ball of plasma 1,300,000 times the volume of Earth. Multiply that by 4 million. Now feel the gravitational pull of that. Feel the way space curves around it. Feel the way time slows down near it, because that is also real. Near a massive object, time genuinely runs slower. An atomic clock near the surface of the Earth ticks more slowly than one in orbit. GPS satellites have to correct for this effect, or the navigation would be wrong by kilometers. General relativity is not a theoretical curiosity. It is baked into the technology in your pocket. The universe has rules, and the rules are active all the time, whether you're thinking about them or not. Fourth, let awe be a methodology, not just an emotion. Awe slows thinking down in a useful way. It interrupts the tendency to pattern match too quickly, to sort new information into old boxes before you have really looked at it. Research in cognitive science suggests that awe, specifically the experience of something vastly larger than yourself that requires mental accommodation, expands the capacity for systems-level thinking. The feeling you get looking at the night sky, that vertiginous, slightly breathless sense of scale, is not a distraction from thinking clearly. It is a preparation for it. Use it. Fifth, take the silence personally, but not tragically. The silence of the cosmos does not mean you are insignificant. It might mean you are rara. It might mean the work of becoming a thinking, questioning, understanding species is the hardest thing the universe has attempted in 14 billion years, and that you are part of it. Every question you ask, every attempt to understand rather than to merely survive, every moment of genuine curiosity is, in some sense, the universe trying again, trying to understand itself. The silence is not a verdict. It is a context. Escucha. There is one more thing, and it is the most important one, and it ties Mars and black holes and the Fermi paradox and the grand filter back to the room you're sitting in right now, and the particular quality of the air in it, and what you will do when this video ends. The reason to care about all of this, the reason to spend time on questions this large when there are so many smaller and more immediately pressing demands on your attention, is not that you will personally solve them. You might. Unlikely, but genuinely possible. Stranger things have happened. The reason to carry is what the caring does to you. What happens to a person who has spent rel time, sitting with the question of why the universe is silent? Or what happens inside a black hole's event horizon? Or whether Mars could ever be a home, or whether the great filter is behind us or ahead? What happens is that every other question they encounter for the rest of their life is slightly different. Slightly more open, slightly less quickly sorted into a predetermined answer. The person who has genuinely wrestled with cosmic scale carries something with them that is hard to name but immediately recognizable. A tolerance for complexity that does not tip into paralysis, an appetite for the genuine rather than the convenient, and a deep structural refusal to stop asking. That refusal is not optional. Not anymore. Not at this point in our history. The technologies developing around us are moving faster than our ethical and political frameworks can track. The questions about artificial intelligence, about synthetic biology, about geoengineering, about the governance of space itself as we extend our reach into it. These are not questions for specialists alone. They are questions for every thinking person who is willing to engage with complexity honestly. The decisions made in the next several decades will have consequences that extend, one way or another, for millions of years. Maybe longer. The people who engage with those decisions thoughtfully, who bring genuine curiosity and epistemic humility and the willingness to be uncomfortable, will shape outcomes in ways that people who have opted out of the complexity cannot. This is not a speech. This is a description of what is actually happening. The filter is not just a cosmic concept. It is a present tense challenge, and the way through it is not technical genius, though we need that. It is not political will, though we need that too. The way through it is the insistence, daily, stubbornly, joyfully, sometimes in the face of strong social pressure to just be comfortable and quiet. The insistence on asking the real questions. Why is the universe silent? What happens at the edge of a black hole? Can humans live on Mars? And should they? And what would it teach them if they did? What is consciousness, and is it common in the universe or staggeringly rare? What is dark matter, and does its nature tell us something we have not understood yet about the structure of reality? Where does the expansion of space-time lead, and what does it mean for the concept of a cosmic future? You do not have to answer these questions today. You only have to refuse to put them down. One more image, and then we are done. Picture someone sitting in the dark, not out of despair, but out of that particular quality of attentiveness that belongs to people who are genuinely listening. Drums nearby, maybe or maybe just wind. Stars overhead, very many of them. Each one a message from the past. Each one light that crossed distances your brain cannot fully hold. The feeling behind the sternum is there, the scale pressing in from all sides. And instead of going inside, instead of reaching for something smaller and warmer and more manageable, this person breathes out, slow, long, and asks again the question that has no comfortable answer. Where is everybody? And in the asking, something happens. Something quiet but structural, like a foundation being poured. The question takes up residence in the architecture of the mind. It opens a door to a room that does not close again. And from that room, every other question looks different. Every problem has more dimensions. Every apparently settled answer has a crack in it where light could get in. That is not a bad place to live. In fact, for the kind of being that we are, for a species at the particular junction in its history where we now find ourselves, it might be the only safe place to live. Not in certainty, not in comfort, but in the full, clear-eyed, slightly terrifying, deeply exhilarating awareness of how much we do not know yet, and how much that matters, and what kind of future becomes possible for the species that refuses to stop caring about the answer. The silence is still out there, vast, complete, waiting, and so it turns out is everything.